showing my space this OBS. Okay guys, I think we are good to go. So this is it. We look at our system. What do? We check our number of nodes. We have 1, 2, 3, 4, 5, 6. But guys, remember, under this case we only have 4 nodes. You can see 3 is being repeated. It's being repeated 3 times. So it simply means it is only one node where these springs here are being connected at different position, but it is one node. So under this case we have 1, 2, 3, 4 node. So if we have 4 node, it means we have a matrix of 4 by 4. So what do? We look at each system and then we expand it. We can call this one system 1. You have the freedom. You can call this one system 2. You can call this one system 3. Easy as that, Mr. Koto. You come, you write, remember K1. What is the spring of K1? Actually, you can do it straight. K1 is between 1 and 3. So you can write 1 and 3. What is the spring? 500 minus 500 minus 500 and then 500. So we are done with that one. So what else do we have? We have K2. K2 is between 2 and 3. You keep the same order. You have 2, 3. Remember this one is 1, 3. This one here is 2, 3. So you also have 500. You can just do it the way I'm doing it. Straightforward, Mr. Koso, guys. Nothing hectic. Guys, today we're gonna do this thing once off. We don't have to expand like everything. We're gonna do them expand once and see if it's best for us. It will save us time during the test. We're expanding because it was our first time. I believe that we are comfortable with this. So this one here, the third one is between 0.3 and 4. So we can write 3, 4. What is the value? Is 1000. You have 1000. You have 1000. You have minus 1000. Minus 1000. You have 1000. You have 3 and 4. Okay, we all know that these matrices will be expanded. It will be expanded to a 4 by 4. So now we're gonna write it. They call it the global stiffness. It's 4 marks. That's the reason why we're gonna try to write it once without expanding to save time. Instead of expanding 1, 2, 3 and then you add, we can do it like this. The K global, remember, we do K1 plus K2 plus K3. I believe that this is fine. So far so good. So we all know that this K global, it has to be a 4 by 4 because we have 4 nodes. I know here it's looking like we have 3, 6, but it is 4. Node 3 is being repeated. It's only one node that is being repeated. So please do not make that confusion. Now you can write with the way we know it is U1, U2, U3, U4. Same apply here. U1, U2, U3, U4. Okay, now how do we do this one straight? You know that K1 is between 1 and 3. So you look at 1 and 3. You look at 1 and 3. You look at here 1 and 3. So this point here, they will be along this 4 spot here. So what do? Under here you put 500 minus 500. This how we do it straightforward. Here we have minus 500 and then we have 500. So you've done this first one. Straightforward. K2. K2 is between 2 and 3. So between 2 and 3, this is between 2 and 3. So 2 and 3. Oh, 2 and 3, 2 and 3. So we are here 2, 3, 2, 3 with this one. You can see this 4 point. Now what is happening here? If you're not comfortable with this one, you can expand all the 3 matrices. I'm pretty sure you guys know how we do it because we've done it a couple of times, and then you add them one by one. Now here we go. We know that this one is between 2, 3. So this is 2, 3. This one is 2, 3. So they're all gonna meet around those 4 points here. So what do we have? We have 500. You have minus 500. You have minus 500 here. Now what's gonna happen? You have 500. This 500 with this 500 will be adding. So it's gonna be giving us 1,000 here. This is the method when you do it once. Now, what else do? We look at the third matrices between 3 and 4. And 3 and 4. So it's between this point here, this one, and then this one. So now, what do we do here? We have 1,000 here, 3 and 4. 1,000 will add with this 1,000 here. It will give 2,000. Now, what are we gonna have here? Minus 1,000 on this side, minus 1,000, and then this side 1,000. So what do we do with the rest? You add 0 on them. So this is how you do it straightforward, expanding once in the matrix. Any question regarding this? The reason why I'm showing you this straightforward, because this thing is 4 marks. If you waste your time on expanding, it is right, it's fine, you're gonna get it right, but remember it's a test. We need to know how to work with time. What is this thing? I can see. We need to know how to work with time, how to manage time. Time management is important. So if we do this, guys, we should be fine. Now, Mr. Goldso and my guys, as you can see today, I'm a bit low. I'm not really okay, guys. I'm not fine. But I had to be there because I know that you guys are hatching and you guys have to be ready. Now, Mr. Goldso and all my people, we have answered number 1.1. Any question about this? Any question? Any question? Can I move? Guys, please, I would like to push this thing and
Yes, move.
we gotta have some rest. Yeah. So guys, this is, it's not bad to be honest. Question 2, they say the displacement of all node 3. These all node 3 here will have different displacement because they are all attached at different position. Okay, let's do it. Remember, we still go with the same sample of formula that we know from mechanics. We know that force is equal to K times X. K is the spin constant, X is the displacement. So now, but remember, now we apply the concept on the global matrix that we found. So how do we do this? We have, how do we do? Okay, we know that for the first node, let me just write first node 3. If you guys remember what I've told you, if you see a support point like this, it simply means the displacement around this point are 0. That are the reason even they are asking you to get the displacement of all the node tree. So this question could have been just say find all the displacement around this question, around this figure, but there's only one to find. It is the tree here. All the displacement around tree, because all these here they are fixed point, and whenever you have a fixed point, the displacement does not exist. It is 0. So now for the first one, it is between 1 and 3. So what do? We come to our equation. Guys, whatever the form, whatever the shape, Mr. Kotsu and all my people, let me do this. Whatever the form, whatever the shape, doesn't have to scare you. We follow the same procedure. We know that it's between 1 and 3. This is 1, and then this is 3. Between 1 and 3, what do we have? We have this one, we have this one, we have this one. This is between 1 and 3, and we have this one. So this is what we'll be having between 1 and 3. So we're gonna be having force. Let me write F1, let me write F3. This is what's gonna happen. Follow this formula like this. To be equal, we write our guys here, 500 minus 500 minus 500, 2000, everything multiplied by the displacement of u1 and then u3. This is what's happening, Mr. Kotso. Remember, this one is also u1 and u3. Now what do? We do our multiplication, straightforward, nothing much to think. Remember the procedure, it is u1 times this and then u3 times this. Same apply, u1 times this and then u3 times this. So what will we have? You're gonna have f1 to be equal to 500 u1 minus 500 u3. Down here, what do we have? You have f3 to be equal to 500 u1 minus, no, there's this minus here, this one is here, plus, I guess this is 2000, not 200, plus 2000 u3. Now remember, we come back to our figure. Do we have the displacement u1? Yes, it is 0. u1 is 0. u1 is 0. Why? Remember, 1 here is a support point. The displacement does not exist. Now the first displacement at u3, what do we get? Do we have f3? No, we do not have f3. Do we need it here? No. Remember, do we need f3 here? Yes, we do need them. Remember, let me stretch. Remember, what do we have as information? F3 is provided here under this case here to be 3 kilonewton. So you can keep it in newton or you can convert it, it's up to you, but let's convert. So what happened here? Do we have F1? Do we have the first F1? No, we do not have, but do we need it here to solve the first U3? I don't think we need it. Remember, we have F3, which is 3 kilonewton here. So you're gonna have 3000, guys. You have minus, remember u1 is 0, so this one will be 0. So what are you left with? You are left with 2000 u3. So if you got to do this, the first node, the displacement u3 that you have here will be 3000 divided by 2000. Any question, guys? You get 3 over 2 here as displacement. 3 over 2, is it meter or millimeter? Let's double check what is the unit provided for the springs. It is kilonewton meter, therefore that displacement there is meter. Remember, under this case I'm not using F1 here to solve because I do not have this force F1, but I do have F3. This is one of the reasons under the following question they ask you to get the reaction force on node 1, 2 and 4. This force that pull back there. So yeah, what else do we do? What else do we do, guys? Sorry. Oh, my head. Okay, okay. Can we look at the second node? I wish I had my SIVA calculator. I wanted to try something. I wanted to try something, but anyway, no problem. This is the second one is between 2 and 3. Second node of 3. Second node of 3 between 2 and 3. So what do? We do the same thing, guys. So we do the same thing between 2 and 3. What do between 2 and 3? This is what we have. Ah, je crois. Can you guys hear me? Is the wife? Can you hear me? Hello.
Yes.
Oh, okay. Okay, guys. For U2 and U3, it seems like it's the same equation. I don't know if you guys see it. U2 and U3 is the same as this one. Wait, did I do the right thing between U1 and U3? Yeah. U1, U3, U1, U2, U3. It is the same as well. 500 minus 500 and this going in. So now what do? Let's do it again. Oh my goodness, what do? We have F F2, F3. Yeah, this is what we need. F2, F3. What do we have here? F2, F3. What are those matrices? Yeah, it is 500. Sorry guys if I'm freezing. Minus 500 and 2000. You guys can see this is U2, U3, U2, U3. Look at how I'm writing. I'm doing this because we are solving for displacement. Now what do? Same thing. The reason why these two equations look the same because we have similar values, guys. It is not something to claim. You see it from your equation. It's just a coincidence. It is not something that is there 100% of the time. No, it's a coincidence in this case. So what do we have? We have F2 to be equal to 500 times U2 minus 500 times U3, F3 minus 500 and then minus 500 U2 and then plus 2000. I don't know why I'm writing 200, but it's actually 2000. Now what do we do from here? remember, we look again on our drawing, we know that f2 is a fixed point. I mean 2 is a fixed point, so definitely it is 0. It is 0. So what do we have here? Do we have f2? No, we will not have it. We leave it like this. It's a reaction 4. We're gonna find it later. Now, but remember, u2 is 0, so this is 0. Now, what do we have here? f3 is given as who's joining? Oh, Mr. Bubakar. Guys, please stop me if I'm fast or you don't understand. f3 is given as 3 kilonewton, which is 3000, to be equal to minus, remember this one will give 0 because look what's happening, plus this one gives 2000 u3. The u3 under this case here still also give 2/3 meter. Now this actually makes sense. Why? We can see these two springs here, they have the same values attached definitely at the same position. You can see parallel, so these two values, they actually make sense. Now what is the last u3 is between this and this, but what do we notice under this force here? Under this one here, we notice that we do not have any external force applied here. Remember what I said, if you have something empty like this without an external force, that force is actually 0. It will be proven even when we find reaction forces. Now what do we have here? That one is between, let's check, is between what? It's between 3 and 4. Between 3 and 4, this is what we have. That's it. 2000 minus 1000 minus 1000. I guess this one is 1000. So now we move between 3 and 4. So same thing. Now we're gonna start. We're gonna write f3. We're gonna write f4 to be equal to, what do we have here? I think it's minus 2000. 2000 or minus 2000. Let's double check. What did we get? 2000. It's not minus. My bad. 2000. I'm at 2000. Minus 1000. Minus 1000. And then you have 1000. Everything here between, is it 3 and 4, right? u3, u4, and you have u3, u4. So what do we do? Yeah. Click, we move it up. Remember, f3 is not provided, therefore it is 0. So f4 we do not know because it's a reaction force. We'll answer it later on. So if I can write, I can only write this first formula. As you can see, I will write f3, which is 0, to be equal to 2000 u3, and that's even justified, and this time this 2000 u3 minus 1000 u4. Remember the displacement at u4 here, the displacement at u4 here is 0 because is a supported force. Okay, what did I say again earlier? It's a fixed point actually. So u4 is 0. So if u4 is 0 and the first f3 here is also 0, do you see what's happening? It simply means 200 u3 here. Therefore, the displacement on the third one u3, it does not exist, which is 0. So now guys, if you have done this, all this that we've done, you have definitely answered this question that has 10 marks. Now the reaction forces on node 1, 2, 3, 4. Okay, what do we do? Note 1, 2, 3, 4. Reaction forces. It is still the same principle. Now we still use the same formula, the same principle of F1 equal to Kx, this one that you see here. But now we need the displacement. So what are we gonna do? We're gonna write the total force of everything, including all the displacement. If you guys remember, we did something like this yesterday. Let me just rewrite it, you see what I mean. Remember, you have F1, you have F2, you have F3, and you're gonna have F4. This is how we answer the reaction force. You copy. Oh god. Oluwa. You copy your matrix here. Can I highlight it? Let me see. Technology is nice. Why should we suffer? Let me escape. Oh. Hallelujah. Yeah. Control C. Scroll down, Mr. Bubakar. Technology is nice. There's no need to Control V. Nice. All I need to do is to escape. Delete this one. No problem. No problem. Delete this one. And move this one here. Nice. That's it. That's definitely it. So this is it. Now everything will be multiplied by our displacement. Sorry. Everything, oh, this means will be multiplied by u1, u2, u3, u4. Now what do? We do F1. This is how we do it. F1. Remember what's gonna happen. You're gonna be having u1 multiplied by this, u2 multiplied by this, u3 multiplied by this, u4 multiplied by this. That's what you get for F1, the reaction force there. Now let's go. For F1 you're going to have 500 u1, u2 multiplied by 0 is 0, minus 500 multiplied by u3. What else do we have? u4 multiplied by 0 is 0. This is what we get on F1. You come down here, you do F2, same thing. u1 multiplied by this, u2 by this, u3 by this, u4 by this. This is how you get the reaction forces. So 0 multiplied by u1 is 0, 500 multiplied by u2, you have 500 u2, minus 500 multiplied by 300 by u3, sorry, minus 500 multiplied by u3. Now you have 0 multiplied by 4, which is 0. You move to F3. Easy as that, guys. You can watch again this video. I will have to send the recording of this. It's recording, that's the good thing. So now we have, but I think it's pretty clear. If you have a question, please stop me. Minus 500 times u1. Now this is multiplying this, this is multiplying this, minus 500 times what is it, u2, plus 2000 times u3 minus 1000 times u4. Again, we move it up here. Here, what do we have? We have f4. f4, u1 multiplied by 0, u2 multiplied by 0. So what you have is minus 1000 multiplied by u3 and then 1000 multiplied by u4. So now what is next? We do our substitution, and you guys, you see what's happening. Class, I want you guys to take your calculator. If we have to calculate f1, what do we do? Remember, the displacement at 1 do not exist, so this one is 0. So at f1, what you have, it is minus 500 multiply. Remember, u3 was 2 over 3. What do you guys get as a force here? What do you guys get?
Minus 333.3333.
Can you give it to me with a fraction? Okay, it's minus 1000 over 3.
Yeah. Yeah, it's minus 1000 over 3.
Now, this case here also here, we're going to have the same thing. Remember, u2 is 0 is a fixed point. So this give again minus 1000 divided by 3. Now here we need our calculator. u1 is 0, so this would be 0. u2 is 0, this would be 0. So what do we have left here? We have 200 times u3 2 over 3 minus, no, it's 2000, sorry, minus 1000 multiplied by u4. u4 is 0. u4 is 0. So now if we do this one, what's happening here? What we are getting here, this one
I
is
could
0.
choose 4000 over 3.
It is 4000 over 3. Now last force, what's happening here? f4. f4, remember, do we have u3? Yes, we have minus 1000 multiplied by 2 over 3. Yes. Now this one gives 0. u4 is 0. So what do you have here? You have minus 2000 over 3. Now here's the trick about this. Look what's happening. If you had these forces here, this, you're going to have, oh, Wi-Fi. Hopefully the Wi-Fi is back. Okay, what I was trying to say, since it's recording, if you have these three forces here, minus 1000, minus 1000, minus 1000, it's going to give you, oh, let me refresh. Slow network. Why is it doing this now?